that leads to hypermethylation. The Fragile X mental retardation gene is susceptible to the accumulation and the anticipation of CGG repeats, and CGG repeats are a combination of the cytosine guanine is very susceptible to methylation, which has a tendency to decrease the successfulness of transcription. It's an epigenetic factor that a lot of our genes use to turn off and on genes and differentiate amongst what cells become the different types of cells. Problem is, normally if the Fragile X mental retardation protein is under 55 repeats, you're considered to have a normal phenotype. Nothing's wrong with you. But the problem is that through anticipation, these CGG repeats start to accumulate, and when you get, you can have reduced penetrance up until about 200 repeats, but when you get above 200 repeats, then you start getting into the full effect of the mutation. And what happens is in the promoter region, there's so much methylation that in the promoter region, the 5' untranslated promoter region, it knocks it out. You get no transcription, no translation, no expression of the Fragile X mental retardation protein, which is a restriction protein, and it restricts downstream other downstream proteins from overaccumulation in the cell, and that's what Enes is going to start talking to you about.
So what we were seeing here is the absence of MRP, which is like a microRNA, is a protein that controls post-transcriptional the other family. Other explanation, there are many other proteins. They control several other protein functionality receptors in our neurons, which I will talk about it in a minute. But what we see here is if we have a normal FMRP, it binds to the mRNA of the other post-transcriptional expression, and then it inhibits ribosome to express it. But when we have absence of FMRP, we express it. We express it uncontrollably, so there is overexpression of EDER, which induces a lot of A to I editing. So there's complementary issues in there, but then it somehow increases the expression of TOR1, TLN1, SASH1, as well as glutamine receptor 2. It also affects its calcium controlling. What are glutamate 2 receptors? They regulate calcium permeability. So they are part of like GABA receptors. And what does GABA receptors do? They control the excitability. And our disease is also related to autism spectrum disorder, which is related to the hypersensitivity, and also hyperactivity is also related, as we were talking about it. And what does the TOR and TLN1 and SASH1 do? We don't know it, but I was searching about it. It was talking about hypersensitivity again. They just seen this phenotype, but they don't know exact mechanism of it. But they also see that you might heard mTOR and stuff. They control the cell cycle. So, did I explain it?
Yeah.